Looking at number 6 from the 2017 BC exam. There we go. Okay, so they give you f of 0, f prime of 0, then a formula for all subsequent derivatives. They do tell you that f is differentiable for all orders for x's between -1 and 1. So they are giving you the radius of convergence, and they tell you again right here when absolute x is less than 1. So write the first, not right, but show that those are the first 4 non-zero terms. So that's kind of nice. They gave them to you. We do have to figure out what the general term is. So if I'm going to write out the first 4 terms of Maclaurin series, in my opinion, it's easiest just to use your general formula, which is the nth derivative at 0 over n factorial times x to the nth power. And so we already have f of 0 and f prime of 0. I need to find f double prime of 0. So f double prime at 0 is going to be, and so I'm plugging in 1 for n, and so that would be -1 f prime of 0. And f prime of 0 is 1, so it's going to end up being -1. F triple prime of 0 is going to be when n is 2, so that will be -2. F double prime of 0, and f double prime of 0 was -1, so it's going to end up being +2. So now I have my, I would write my first 4 terms. Oh crap, look what they did, these little turds. Okay, so here's what I'm noticing. F of 0 is 0, so my first term is 0 plus, and then f prime is 1 over 1 factorial x to the first plus f double prime, which is -1 over 2 factorial times x squared. And then f triple prime is 2, so it would be 2 over 3 factorial times x cubed. And here's where they turned into little turds, because they want the first 4 non-zero terms, and my first term is 0. So now I have to go on and find the value of the 4th derivative at 0, which is going to be when n is 3 in this formula. So it's going to be -3 f triple prime of 0, which would give me -6. And so that'll be plus a -6 over 4 factorial times x to the 4th. Did I mess up? 4 times 3. Oh, no, okay, never mind. Wow, okay. For some reason, I was thinking -6 over 4 did not equal 1/4, but it does. I now am going to reduce these to show that these 4 terms right here do actually reduce to those 4. And so 1 over 1 is obviously 1. 1 over 2 factorial is 1/2, so that's x squared over 2. 2 over, let's see, 3 factorial is 6, so 2 over 3 is 1/3. And then -6 over 4 factorial. 4 factorial is 24, so -6 over 24 would be 1/4. And so I have now shown that those are indeed the first 4 general terms. I'm sorry, the first 4 non-zero terms. And then the general term is going to be, I think what I'm going to do, I'm just going to find the general term based off the pattern. Usually I will throw in, if they give me a formula for the derivative, I'll just throw that in the numerator, and I would say like -n f to the nth of 0, but that's going to be really confusing because the n and the n plus 1 here in this formula are kind of throwing me off. So I'm just thinking out loud here. So looking at my terms are x to the n over n, and it does alternate, so I need to give myself an alternator in here. So that'll be -1 to the n, and now I need to look at that alternating component and make sure that it gives me a positive first term. And my first term, I generally like to think my first term is when n is equal to 1. This is when n is equal to 2, and when n is 1, I need a positive term. So -1 to the first will not do that. I need to make this -1 to the n plus 1. And now I have a general term that does fit these 4 terms here. So then part B, determine if your series described in part A converges absolutely, conditionally, or if it diverges at x equals 1. So my series is this. N goes from 1 to infinity, whereas there he is, N goes from 1 to infinity of -1 to the n plus 1 x to the nth over n. And if x is equal to 1, I would have the series -1 to the n plus 1 over n. Now, this is a very, very, very simple series. You should know right off the top of your head that this is going to be convergent as written because it is the alternating series. It is alternating harmonic series, but they do want you to explain your reasoning. So I need to explain how I know that this converges as written. And so this converges by the alternating series test. And the alternating series test is that your terms approach to zero. So if you ignore the alternating aspect of it, the limit as n goes to infinity of 1 over n does indeed equal 0. And you want to show that the terms decrease. Is the n plus first term less than the nth term? And if you plug in n plus 1 for n, you have 1 over n plus 1. A sub n is 1 over n, and that is true as well. So the terms do approach 0, and they are decreasing. Combine that with the alternating component, and this does converge as written. Now, absolute convergence means that the absolute value of the series also converges. So I already know this is convergent in some way. So diverges is out of the question. Now the question is, does it converge absolutely? Well, if I take the absolute value of this series, I end up with just your good old harmonic series, which does diverge. And so the absolute value diverged, yet the original series converged. That is the definition of conditional convergence. So therefore, conditional convergence. So there is your answer to part B. Part C here introduces a function g, and they want you to write the first 4 non-zero terms for g. Anytime I see an integral defined function, one of the very first things I'm going to do is connect it to its derivative. G prime of x is going to equal f of x. And I like connecting g to f in this way because then I can use this information up here to find the first 4 non-zero terms. And so what I would like to do is just find g of 0, g prime of 0, g double prime of 0, and g triple prime of 0. And hopefully I will not get any zeros in return because that would be my four terms for g. So g of 0, g is the integral from 0 to x. So g of 0 will be the integral from 0 to 0. And unfortunately, that does equals 0. So that one's no good. G prime of 0 would be f of 0. And that, unfortunately, is 0 as well. So at this moment, I know I need to go at least down to my 4th derivative of g and my 5th derivative of g. I know I've got to go at least that far to get my 4 terms because my first 2 return to 0. So g double prime is going to be, if g prime is f, g double prime is f prime of 0. F prime of 0 is 1. G triple prime would be f double prime of 0. And I think we did that in part A. Yep, f double prime of 0 was -1. G, the 4th derivative of g, will be the 3rd derivative of f. And the 3rd derivative of f is 2. And the 5th derivative of g would be the 4th derivative of f. And that was also in part A, which is -6. Okay, so my first 4 non-zero terms are actually going to start with g double prime. So my g of x is going to be approximately g double prime, which is 1 over 2 factorial times x squared, plus a negative 1, and this is my third derivative of g, over 3 factorial x cubed, plus 2 over 4 factorial x to the fourth, minus 6, or plus a negative 6, over 5 factorial, because that was my fifth derivative of g, x to the fifth. And there is our function for g. And so now we want to come up with a general term. Let's see. So this thing, I'm going to clean this up. That's x squared over 2 plus minus x cubed over 3 factorial, and the general term. This general term is stifling me a little bit. X cubed over 3 factorial plus 2x to the fourth over 4 factorial minus 6 3. Okay, I'm seeing it. Wow, okay, I think I'm seeing it. This is a little bit tricky. Over 5 factorial x to the fifth. And now for my general term, so what I'm noticing is I have x squared, and I think this is going to work, over 2 times 1, minus x cubed over 3 times 2. And this would reduce, 4 factorial is 4 times 3 times 2. Those 2's would cancel. So I have x to the fourth over 4 times 3 minus, and 6 happens to be 3 factorial. So 6 is 3 times 2 over 5 times 4 times 3 times 2 is going to give me x to the fifth over 5 times 4. And so my general term, what I'm seeing is that this alternates. My first term is, which I like to think of as n equals 1. It's x is an even, is a positive number. So this is going to be negative 1 to the n plus 1. And so my first term is x squared. So it's going to be x to the n plus 1. So that gives me 2. And on bottom, we have n times n plus 1. And that's going to give me my denominator. So if I try plugging in, just for example, this is my n equals 3 term. So if I plug in 3 for n, that'll be negative 1 to the fourth, which would be positive. X to the 3 plus 1 would be x to the fourth. And then I have 3 times 3 plus 1, which would be 3 times 4. So that gives me my general term. And so there we are with part C. And that general term was a tricky one, but there we have it. And then finally, part D. I think I'm going to use this answer in part D. Part D, so we have the nth degree Taylor polynomial for G about 0. So that is what we found out in part C, the Taylor polynomial for G. When it's evaluated at 1/2, we are to show that the error in using the first 4 terms is less than 1 over 500. Okay, so this is our error. And so I'm going to go back and copy this so I can look at that in this question. So edit, paste. All right, so there is my polynomial for G. Shrink that up a little bit. And in an alternating series, in a convergent alternating series, your error is always less than your very first omitted term. And so I'm going to say Pn of x, which they define as the nth degree Taylor polynomial. That's the answer to part C. Pn of x is a convergent alternating series. Therefore, the error in P4 of 1/2 is less than the first omitted term, which is, okay, so my fourth degree Taylor polynomial would be these terms right here. So those represent the fourth degree Taylor polynomial. And my first omitted term would be -6 over 5 factorial times x to the fifth. And I am plugging in 1/2 for that x. So it's going to be -6 over 5 factorial times 1/2 to the fifth. And the magnitude of that, we take the absolute value of that. And that gives me -6 over 5 factorial, which I'm really not good at factorials. And now 5 times 4 is 20, times 3 is 60, so it's 120. Times 2 to the fifth, which is 32. 6 over 120. Oops, that negative shouldn't be there. 6 over 120 would reduce to 1 over 20. So that's 1 over 20 times 32. 20 times 32 is 640, which is less than 1 over 500, which is what they asked us to do. And I'm finally done with this problem. Man, that was a booger.